Welcome to everybody. Welcome to you guys. Today, let us take the solution to the GC 2016 Mathematics paper 3. Okay, so let us take question number 2. Question number 2 was a question about center of gravity. Okay, so the figure we have to work with it today have been displayed to you already. So let us have the question. So the question says, Figure 2 shows a uniform lamina ABCD of sides 6A meters. A portion of the lamina in the form of a square ATUV, where T and V are respectively the midpoints of A and B, AB and AG, is removed. Okay, so another portion of the lamina in the form of a sector XCY, that is it, of center C, where X and Y are respectively the midpoint of BC and CD, is also removed. A. Show by integration that the center of gravity of the uniform lamina in the form of a sector XCY is a distance 4A on pi meters from the bounding radii. Okay. B. Find the distance of the center of gravity of the remaining lamina from AG. So that is the question. So let us solve directly today. Solution. Okay. So let us have back the question. Let us do it step by step. We first of all start by extracting the sector on our diagram and place it on a graph. Okay, so this is how we are going to represent it graphically. We are going to get this. Okay, so take note, our diagram had a certain point. The point was x cy. Okay, so if you return it, if you just see this normally, I've written it so in such a way that the x should be in this way and the y should be on this way for it to fit here. So our center here is O, which is equal to C. Okay, then we have that. Now, what are we going to do here? We are asked to prove by integration. Okay, that they say show by integration that the center of gravity of the uniform lamina in the form of a sector XCY is distance 4a over pi meters from the bounding radii. Okay, so we get this as the figure that we need to have the center of mass. So what do we start by doing? We start by looking at the equation, because this thing forms a parabola. Okay, but in the same way it's a sector. So the shape of it shows a parabola, a half parabola. Okay, but the shape of it, we know that it's a sector, so it's coming from a circle. You can just complete, you can see it's a circle of radius 3a. Okay, so from that now we can just use as equation the equation of a circle for this sector. So this is what we have now: x squared plus y squared equals to the radius squared. So that is the equation of a circle. So now to use integration for a proof here, you just need to use y bar to be equals to half the integral from 0 to 3a of y squared dx all over the integral from 0 to 3a of y dx. So that is the formula we are going to use for y bar, okay, to have the integral bound the bounding radii. So we get this as a formula. So what do we know about y? To get y, you just simply use the equation of the circle that we have used here. So we use it, we make y the subject, and you're going to get y to be equal to the square root of 3a squared minus x squared. So with that now, there's one thing we need to note. Okay, we need to note that what the integral from 0 to 3a of y dx is the area under the graph. Okay, so it's the area under the graph, and since the graph here is a sector, so it will be the area of a sector. Take note, the integral from 0 to 3a y dx is the area of a sector for this particular case here. So taking all the integrals you are going to be taking when you are asked to prove by integration, the integral which is found under, okay, the integral from any point to another point of y dx is the area under that graph, okay, or under that line is the area under. So take note, since here we are dealing with the sector, we are going to take the area under the sector. So the area under the sector is given by pi radius squared theta all over 360 degrees. This is when theta is in degrees. Now here, the theta here is 90 degrees. Okay, what the angle this one makes for with the remaining body with the axis here is 90 degrees. Okay, we can see that. So the angle here is 90 degrees. So substituting that, now we have the area to be equals to pi into 90 degrees times 3a squared, that is the radius. Don't forget it's a sector. So from the center to this point here is the radius, all over 360, and you get down the area to be 9 pi a squared on 4. So you have already gotten this other part down. Okay, so you have gotten this. Now the next thing is to find this integral. So we know already our y. So what do we do? What are we going to do? We are going to integrate now y squared. Okay, from 0 to 3a dx. Okay, we get that. So integrating this is not really complicated, as we know, or integration is not a problem. Okay, so to integrate this, you replace the value of y, you square. When you square, the square root disappears. And what do? You just have to integrate everything with respect to x, because we are talking about the x here. So integrating everything with respect to the x here, you are going to get 9a squared x minus x cubed on 3. Do you see that? So when you see this 3a here, I've just said 9a squared y, because 9a squared xy, because here is just like a constant, it's just like 1 in this function. Because if you have something like 1 minus x and you are asked to integrate it, you just have what? X minus x squared over 2. So this 3a there is just like 1. So it's just like it's not, we cannot really, it's just like a constant. Okay, but since you are integrating with respect to x, it will not tend to become a function of x. So we get this. You will now simplify and replace the value of 0 of 3a, and you subtract from when it is 0. So when it is 0 here, we can already see everything becomes 0. So you just replace for 3a and you simplify. You're going to get 1 over 2 into 54a cubed over 3. So we get this for the integral for the upper part. Now what do we do to get y bar? You just have to divide the 2. So when you divide down the 2, you get what? You get half into 54a cubed all over 3 divided by 9 pi a squared over 4. So when you do this correctly and you simplify, you get 4a on pi. So you both should do the simplifications and tell me in the comment section if you had the same answer, or if the proof came out. Okay, so if you do it and you don't have the same answer, please tell us your answer. Let us verify and see. So that is it. You have this. Now let us do the next part. The next part talks about what? They say they find the distance of the center of gravity of the remaining lamina from AG. So now what do we know first? We know that this whole lamina here is a square. Okay, and inside the square is what? Another square and a sector. So we start by letting mu be the weight per unit area, which implies that what? The weight equals to the area times mu. So we now produce a table. Okay, so for this table here, we have what? The portions on one side, the weight on another one, and the distance of center of gravity from AG, because we are asked to look for AG. So we start ABCD is a whole square. Now what is the area of the square? We know that the side here is 6a given by the question. So what will it be? It will be 36a squared times now what? Mu. So we get this. Now the distance of the center of gravity from AG, from the center of the square to the point what? To the point AG. Okay, so what will it be? It will simply be 3a. Okay, because from the center to that point AG, so that distance covered is since the whole from B to C is 6a, you divide by 2 and you're going to get 3a. Okay, now let us take ATUV, which is the other square inside the square. You know that these lines here falls exactly at the midpoint, so the only distance from A to T here is 3a. Okay, it's already halfway. So we now take also its distance from the center to that point. You're going to get what? You're going to get 3a on 2. As we know, the area of that square now will be what? Side times side, which is 9a squared mu. Now xcy, we calculated xcy for the behind, but we are not going to replace it here, because for the area now of this xy will just be what? The area of the sector. Take note, the area is just what? The area of the sector as we calculated behind. So what will it be? It will be 9a squared pi on 4 other times mu. So that is the area of that figure. Now for this other one, yeah, we are taking what? The distance from the center of this body, which was denoted to be C, up to this point, up to the line AG. So what will it be? We have already calculated the center of gravity for this small sector. Okay, and we have gotten it to be what? 4a on pi. Now we know that the total length here is what? 6a. Now what will be the distance from the center of gravity of this sector to that? It will be what? 6a minus 4 pi or minus 4a on pi. So the first part of the question directly help us to have the second part. If they were not the first, the first part was not there, then when you just have to calculate the distance of the center of gravity of the remaining lamina from AG, you are now going to do all the work that you did up at the first part here now before getting this distance. Okay, so you just see how the questions are related and good. one work with the other. Okay, so now what will be now the weight of the remaining lamina? It will just be what? It will just be the weight of of this square here, okay, plus the weight of the whole body. So what do we have? We have this is the general weight, the final weight. You just take this weight plus this weight and you subtract the two. Okay, so you take ATUV plus XCY. Now you take 36 minus the sum. You simplify, you're going to get this times mu, which is common. Now the distance from because the remaining one don't have the square and the sector again, so it's just like on shape. So that distance will be from the center of that funny body to the line AD, and we are going to denote it as x dot dot. So having all of that, now we are just going to be taking moment. So we take moment about AD. What will it be? What are we going to apply here? We're not going to say moment of ABCD will be equal to what? Moment of ATUV plus moment of XCY plus moment of the remaining body. So how do we get it? We know that the whole body here is a square. So the moment of this square will be equal to what? The moment of the other square inside plus the other moment of the sector plus the remaining moment. So that's what constitutes the whole final square. So having that, now you can make now the moment of the remainder the subject, and you find for x dot dot. So for this other case, you are going to do the manipulations and tell me if you simplify it correctly. I'm sure you are going to get this. If you get something, please notify us in the comment section. So that is an exercise. So simplify it, replace the moment. So take note, the moment is the force times perpendicular distance for each case. So manipulate and make moment of the remainder the subject, then furtherly make x dot dot the subject, and you're going to get 46 minus 6 pi all over 12 minus pi a. So please do it. It's an exercise. Okay, so that is all for the video. So I thank you all guys for watching. Please like, comment, and share the video. Okay, so don't forget, I'm waiting for I'm waiting to you to tell me if you have succeeded in having this proof. Okay, so take it as a proof. Yeah, if you don't have it, tell us your answer in the comment section. So I thank you all guys for watching. We'll see you in another video.